There are 6 mannequins, 2 identical males, 2 identical females, and 2 identical children. And the question is, in how many unique ways these can be arranged in a row? First things first, this is an arrangement problem, not a choosing problem. For a moment, let's pretend that the 6 mannequins are all different. So they can be arranged in a row in 6 factorial ways. If they were to be all different. In reality, they aren't. There are actually 3 different groups of 2 identical pieces. So we need to apply the Mississippi rule over here. What's that rule about? In a set of n items, if B are identical and of one type, C are identical and of another type, and D are identical and of a third type, so there are 3 different types, the total number of distinct ways the n items could be arranged is given as factorial n over factorial B times factorial C times factorial D. And this is exactly what we are going to use in our formula. In our case, n is equal to 6. The total number of mannequins. B is 2. That's the number of male mannequins. C is also 2. That's the number of female mannequins. And D is also 2. That's the number of child mannequins. So we have this as factorial 6, that is 6 times 5 times 4 times 3 times 2 times 1 over factorial 2 is 2 times 1 times factorial 2 times factorial 2. So we have a 2 here and a 2 here and a 2 here. So 2 times 2 times 2 is 8. We can cross out the 4 and the 2 from the numerator. So we are left with 6 times 5 times 3. 6 times 5 is 30. 30 times 3 is 90. So the number of unique ways in which the mannequins can be arranged in a row is factorial 6 over factorial 2 times factorial 2 times factorial 2, which is equal to 90.